The circle is on my left and the star is on my right. Okay. All right, so that's what we covered last time. For today, we're going to continue to take a look at the graph and kind of review a little bit. But we're not looking at the graph today. We're going to use algebra to decide if the function is continuous or not continuous. Okay, so for a function to be continuous, that means when you draw the function, there's no gaps, no hole. They just are together, right? So we're going to look at today, the second objective we're going to look at is continuity, but we're going to use algebra to prove it. Okay, so remember when we have the discontinuous is when we have the graph. I'm going to draw that again. If we have like a hole, right? If that is my graph, or if I have another graph and there is a gap, this is also a jump. That's make the function not continuous. That's when we see the picture. Now, for this one, a couple of things that you want to pay attention to is that if the function is continuous, then there's no restriction. Any values would work. If you plug into any x values, if you do the substitution, if you plug it in, it will not do anything to the function. It will be okay, right? However, if the function is discontinuous, that is mean if there is one x values, if I plug it in, it's make the function undefined. Or there's a problem with that. So the problem that we can look at is if we do substitution, x values, and if the x values make the function undefined, then that function is not continuous at that point. So let's look at the first one. Let's look at the simple one. If I look over here, if anyone remember from pre-cal, what value is going to be a problem here? If I look at this function right here. If I'm thinking about the x values, what x values, if I plug it in, then I cannot do any calculation. There's 0. Yes, the 0, right? When x is 0, the reason why, think about this, if I plug it in, it's going to be 1 divided by 0. We cannot do this. We don't know what happened. So this one is undefined. When we think about the slope, it's a vertical line, it's undefined. So we don't know what that is. So this function, if you look at this one, the function is discontinuous at 0. So at f equals 0, okay? So how do we know? So the thing is what we want, and I'm going to draw this in a different color. If we have a 0 divided by some number, then this is okay. But the denominator cannot be 0. So that's the one criteria that we're going to use to test continuity. So what we're going to do, we're not going to test out the numerator, but we're going to test out the denominator to figure out when, because we don't want to divide by 0. If you divide by 0, it's going to be a problem, right? So what you do, we're not going to test the denominator. We will not test the numerator, but we will test the denominator, okay? So let's look, so that's, once we test the denominator, then we can figure out when the function is not continuous. And then we're going to talk about the type of discontinuity. All right, so let's look at the second one. So we know that the denominator cannot be 0. We know that. So what I would do is that I'm going to take this denominator for the second function, x squared minus 2x minus 24, set that equals 0 to 0. Because I want to know what values will make the denominator equal 0. And that is the point will make the function not continuous. Is that confusing? So I'm going to repeat that. We know that the denominator cannot be 0 because we cannot divide by 0. So the goal that I'm trying to do is to figure out what values make the denominator 0. Because those values at the point that make the function not continuous. Are we okay with that? Okay, so I'm going to solve this. We review how to factor this one out as a quadratic function. So I have negative 24, negative 2. What are the two numbers that I have here? What are my two possibilities? Negative 6 and 4. Okay. So x minus 6 and then x plus 4. So the value, so you want to solve for this one, right? So if you factor it out and you want to solve for it, so what you need to do is you have 6 minus x equals 0 plus 6. So x is 6. That's one of the points. And then you would do the same. I'm going to erase this part because I need this space. So I would do the same thing for x plus 4 equals 0 minus 4. So what I can say is that the function, this function, is not continuous at negative 4 and 6. So I'm going to write over here. I'm going to clear this side so that I have space to write that out. Okay. So what I can say is this function is not continuous at x equal negative 4 and 6. So that's how we figure out at what point the function is not continuous, by looking at the denominator and figure out at what point the x values would make the denominator 0. Questions for me in this one? Because we're not looking at the graphs. And the last time we look at the graphs, we see it clearly. There's a hole, there's a gap, there's a jump. But without the graph, we have to do this. So how do we know it's continuous or not? Is that we test out the denominator. Keep in mind we cannot divide the denominator if the denominator is 0. The bottom function, if it's 0, then we cannot divide it. So if you look at the first one, if x is 0, 1 divided by 0 is going to be a problem. So what I would do is I always checked. So what I would do is that I always check the denominator to make sure that is not equal to 0. Okay. So look at the second function. I look at the denominator. I take x squared minus 2x minus 24. I set that equals to 0 because I want to look for what values is make 0. Okay. Anyone else did not have the link for paired act? Let me know. Let's do another example for this one, just so it's a little bit better. So let's look at this one. Okay. We're gonna cross this one out for now. I don't know why I have that. Okay, so clear that. Okay. We're gonna look at the first one. We're gonna determine if the function is continuous or not. So here's a question. We look at this problem right here. This one. Let's look. Let's call this number 3. Okay. Which part of the graph should I check? The 5 in the top or the x squared minus 81? If I want to check for continuity, I want to check for the denominator, right? So I want to check this one. So step number 1, I will take my denominator, x squared minus 81. I will set that equal to, in order for me to check, what do I set that equal to? 0, okay. Now step 2, I'm just going to solve this function. This is a special quadratic function. You can set the diamond, or this one is a special one. is a perfect square, so that would be x minus 9 and x plus 9. Yes. Okay. So to solve for this one, I set each of my factor equal to 0. And then I can solve it. So plus 9. So x is 9 minus 9. X is negative 9. So the function is not continuous at what point then? Based on my answer, the function is not continuous at what point? Negative 9 and 9. So we can say not continuous at x equal negative 9 and 9. So we're going to use algebra to figure out the point where it's not continuous. Cool. Let's look at the next one. Let's do another one. Now, for the second function, look at this one I have. So I'll call this number 4. Okay. For this one, it's kind of, we know the function we have to solve for because the top one is 5. But look at the next one. I have two quadratic function, x squared plus 2x minus 24, and then I have x squared minus 36. Which one will I use to figure out the continuity? Do I use the one on the top or do I use the one on the bottom? Still the bottom one. Doesn't matter, right? Even though I have a crazy function on the top, it's okay. I still check the denominator. Yes, Jessica, that's correct. It's still the bottom function. So this also a special. So step 1, set equal to 0. Step 2, factor it out. Step 3, solve it. Okay. So x squared minus 36 equals 0. And we know this is a special one. So the answer for this one will be 6 and negative 6. Okay, so when say f of x is not continuous at x equal negative 6 and 6. Okay, how do we feel about this? It's okay. More example, or you think you got it and you want to do the practice on your own? Okay. One of the question was, is this continuous? I'm not sure what you mean by is this continuous. Or will there be a non-continuous question too? I mean, this function is not continuous at these 2 points. Anywhere else is okay, but it's not continuous as negative 6 and 6. And after we do this practice, we're going to talk about the types of discontinuity at these points in about 5 minutes. But right now, we just figure out at what point it's not going to be continuous. So this function is not continuous at negative 6 and 6. The number 3, this one right here, is not continuous negative 9 and 9. Is this always the special function? No. So let's do practice. Let's do practice. I'm going to ask you to do this one. Sorry. Okay. I'm going to clear this part if you need to copy. So, I'm going to cross this out. Okay. So I will give you a function, and I think I have a function for you, and now it just disappeared. So let me jump around a little bit. So for the one that you can do, no, that's not what I want. Okay. All right, so I'm gonna clear this. I'm gonna clear the screen. I'm gonna ask you to try this one, okay? And then I will tell you f of x minus 2, x squared minus 5x plus 6. So let's use this function. I know as you already wrote on paired x, if you want to clear the screen, try this one. At what point is not continuous, or is this continuous at all the point? Let's do this one. We're gonna look for at what point the function will not be continuous. So go ahead and solve this one. Try this. I'm gonna look at paired x while you are working on it. If you do in a piece of paper, then you can email that to me. But I'm gonna look at paired x right now. To think about which part of the function you will have to check for 0. Okay, let's look at continuity, but instead of a function like this, we're going to look at piecewise function. Okay. Piecewise function is when you have 2 or more functions put together, and the graph is not like one function divided. You have a bunch of pieces, like a bunch of pieces put together, okay? And we're going to figure out if the function is continuous or not. So for the piecewise function, we have several steps to do, okay? So we'll do a couple examples in this one, and then I'm gonna ask you to try the practice, and then next time we will go back to review the one we just did and talk a little bit further about is this gonna be a removable or non-removable, okay? So let's look at if the function is a piecewise function, and we want to know if the function is continuous or not. There are 3 criteria for the function to be continuous. So let's review. The first one is f of c is defined. My handwriting is much better than this. I'm just really hard to write on an iPad, so I promise you I have a better handwriting. Step 2 is that we're going to check for the limit at that point. If there is a limit, okay, the limits must exist. So that means there must be a limit. And then step 3, we're going to determine if the point at that f of c is the same as the limit. They both equal. And they both equal to the same number. So these are 3 criteria to make the function continuous. So step number 1, we're going to check if that point is defined. Defined means if I plug into the values, there's nothing wrong with the function, I would get a number. The calculator would not tell me it's undefined, or it's not going to tell me it's error. Okay. Step 2, we're going to check for the limit. If there's no limit, and remember how we check for the limit, the last summative that you did, to check for the limit, we test for the left, we test for the right, we compare them, okay? And then step 3, we're gonna check to see if that point and the limit is the same or not. So these are the 3 criteria. So you wanna jot it down somewhere, because when we run into the piecewise function, you have to do these 3 steps if you want full credit from me. So I'm going to give you like a minute to copy it down, have it somewhere. Okay, step number 1, f of c is defined. We want to check for that. Step 2, we want to check to see if there is a limit. Step 3, we're going to check for step 1 and 2 to see if they equal. if the number is the same or not. That's what we look for. Okay. So we're going to do for step 1. How do we know which value to test? Is this one right here. How we know which values? Is the one when the x, the restraint for the x. If they tell you 0, that's the values that I'm going to check. So if I want to check for f, sorry, this is not f, this is h. Because this function is h. So h of 0. Here's a question. I want to see how many of you remember this from pre-cal. If I want to check for h of 0, do I plug it into the top function, x plus 1, or do I plug it into the x squared plus 1? If I want to test for h of 0, which function? Okay, some of you tell me the bottom one. Why? Why do you think the bottom one? Or if you say the top one, tell me why is the top one. Because I cannot test both. I have to figure out which one. So h of 0. Okay, then I have someone say, would that be, so Jessica was like, wouldn't that be the top one? Because it's less than or equal to 0. And that would be where the 0 is included. Okay. Jessica, that's correct. We're going to test out the top one. The reason why we check out the top one, which Jessica already put in the chat, is this part. It's less than or equal to. So we look for the one that's equal to means, look at this one, the equal tell you that it does include a 0. The one at the bottom is like greater than 0. The 0 is not part of that function. So the 0 is part of the top one because of the equal one. So when we test out h of 0, f of 0, f of 2, we look for that equals 1. Okay, so it's going to be 0, whoops. So it's going to be 0 plus 1, which is going to be 1. So it's working. It's okay. I can test it out. There's no problem with that, right? So step number 1, checked. It's good. I got that. So now I'm going to check for step 2. Step 2 is that we're going to check for the limit. Whoops. Step 2, we check for the limit, right? So we're going to check for the limit. If you remember from the last class, we're going to check for the top and we're going to check for the bottom to see if they equal. So we test it out by 0 plus 1 give me 1. Then I'm going to test out the bottom function too, which is 0 squared plus 1, which is give me 1. If they have the same values, is there a limit for this function? Yes, right? If they are equal, the limit is that number. So yes, there is a limit. So step 2, checked. Now what we're going to do is we're going to check for step 1 and step 2. So I'm going to work on step 3 right now. Step 3. So think about h of 0 equal to the limit at 0, which is, look at my step 1 and step 2. Step 1, h of 0 is 1. Step 2, the limit is 1. So they are equal to each other. So I can say f of x, which is, step 3 is also met the right criteria. They are the same. So I can say f of x is continuous at x equals 0. So this one is a lot of steps. I'm pretty sure more than half of you is like, what? So, okay, we'll spend time on this. But right now, what we are trying to do is to prove that this function is continuous or not continuous at this point right here, the one that I just highlighted in green. Okay. So it's a piecewise function. We're not going to sketch the graph, but we're going to use algebra to say if the function is continuous at 0 or not. So question for me in the steps right now. I know there's a lot, but anything that was like how you got that, at least let me know. But I always follow these steps, strictly follow these 3 steps. Okay. If one of the steps fail, let's say if I test out h of 0 and that's give me undefined, then I can just stop. Then I don't have to worry about anything else. I'm like, nope, it's not working. I don't have to test step 2 and step 3. If I test step 1 is okay, I went to step 2 and there's no limit, then I'm not even bothered to go to step 3. I can just say the function is not continuous. So in order for the function to be continuous, all of these steps has to work. It has to be true for all of these 3 criteria. Okay. Other questions? Again, if you miss anything, I always record my lessons. I saw some, I post that, I share the link. I saw that some of you actually view the video. If that helped, do so. That would help you. Skip forward. I know that sometimes I'm just talking things that are unrelated. Just skip forward. Hopefully that'll help. Let's do another one. Okay? Try another one. So there are 3 steps that we want to test out, okay? Step number 1, so we want to test for continuity. So step number 1, I want to test out f of, I want to see if the function is defined or not at that point. So in here, what point do I plug it in? F of what? F of 2, right? So that number, the restriction tell you that's the values that I'm going to test out. So f of 2 f of 2, okay. Now the next question would be, do I plug it into the top or do I plug it into the bottom function? The bottom one, because that's the one with the equal sign, right? Good, thank you. So the bottom one, because that's the one with the equal sign, so I will test that out. So I'll plug it in. So negative 2 squared plus 4 times 2 plus 2. Negative 4 plus 8 plus 2. Do you have to do step by step? Probably no. If you have that graphing calculator, plug it in. This can be 4 plus 2, so this is 6. Okay. So it's okay. What I mean by the function is defined is that if I plug it in, I got a number, then that is defined. That's okay. If I plug it in and the calculator tell me it's error, I don't know what to do with that, then that's not going to be defined. Okay, so in this case, f of 2 is 6. So step number 1 is okay. Step number 2, I'm going to test for the limit. So what I would do, if the 0 is okay, if it's a 0 and it's okay, yes, it's still defined. If I plug it in and give me 0, then that's fine. But if I plug it in and the calculator tell me it's error, then it's not. So for piecewise function, most of the time it should be defined. So step 2, I'm going to test out the limit, right? So I'm going to check for the top one as well. So 2 squared minus 4 times 2 plus 6. So let's see. 4 minus 8 plus 6. This can get me 2. So the top function is 2. guess what? The second function is already, we already test out the second function, right? The bottom right here. So we know, we can say the second one is 6. Since you already tested out for the first one, you can plug it in again, or you don't have to. Here's the question, is there a limit? So this is the left limit, this is the right limit. So is there a limit for this function? No. So step 2 already fails because there's no limit. So no limit. If step 2 is failed, I can stop. And I don't have to go to step 3. I'm not going to compare step 1 and 2 because there's no limit. That is mean the function is not continuous at that point. So now I can go back and say f of x is not continuous at x equal 2. And I can stop right there. So I don't have to go to step 3. Remember the last example? I went and I checked for step 3. But this one I won't because there's no, compare is defined, but there's no limit, so I can just stop. What do you mean by can you use 6? Okay. So this one is new, right? So it's maybe a bit confusing for you right now. But that's okay. I expect that. This one is like always, whenever we run into a new topics, that's what's gonna happen, right? We will get confused. We'll continue with this one. So I know some of you did not ask question because I'm thinking you may not know what question to ask me yet. Because sometimes until you do the practice, then you know what kind of question you're gonna ask me. So I'm gonna ask you to do this. Okay. Go to Schoology. Go to Schoology. And I want you to go to Chapter 1 Practice folder. This is your, I call it extra slipped. We have about 7 minutes, which I think should be more than enough for you to do it. So if you've completed it. So go to Chapter 1. Go to Practice folder. You should see 1.5 Objective B. Continuity for piecewise function. Okay, there are 2 questions for you to work on. The first one is the multiple choice, so you can check in quickly. The second one is the one that you have to show your work. So once you've done with